and it's great to be speaking at the Los Angeles group. Looks like we've got a really good crowd here. I have just a tremendous amount of content that I'd like to get through, but as we go along, feel free to put questions in the Q&A. Greg is going to help me as well, make sure you get all the questions answered anytime. There's no wrong time to ask a question. So a little bit about myself. I mean, if you so choose, you can just do an internet search for my name and just kind of disregard the YMCA karaoke videos that you find and go down to the meaningful stuff. But find out a little bit about who I am. I've been programming for right at 25 years now, and I'm a chief architect at ClearMeasure. We're a software architecture company headquartered out of Austin, Texas, and kind of spread out over North America, focusing on serving .NET teams and helping them move faster, deliver quality, and run their systems with confidence. And our goal is for our customers to have to outsource less because the internal team has gained a better software delivery capability. So that's kind of where I'm coming from. A little about some of the things that I do. Since 2018, I've been the host of the Azure Devops podcast. So if you haven't heard of that, just go to azuredevops.show and you can see all the different show notes. We're over 200 episodes now. And I think if you search for Azure or DevOps, we seem to be in the top 5 in all of the different directories. So pretty easy to find. I also just launched a new online TV show, and it's called Programming with Palermo, whereas the podcast is interviewing guests and kind of getting different experts on there. This one is about just me teaching, and people can watch me program. It literally is brand new. We're up to 10 episodes so far. It comes out on Tuesdays, but you can go to www.palermo.network and you can see, and you can also go to the video podcast directories and search for Programming with Palermo. And we just about 10 weeks ago, we launched that. So I already have some topics on Blazor. Actually, one thing that I'll mention about Blazor that has a full 45 minutes explanation is Blazor WebAssembly with a single web API. Even if you have 100 screens, there's no reason to make 100 web services. You can just create one web service if it's just private to your own application, and kind of 45 minutes of showing that technique, which I don't have time to show it all in this particular setting. And also, it's a couple of years old now, but all the topics are still just as good as they were. My latest book, .NET DevOps for Azure. If anybody, there's my email address on the screen. If anybody would like a complete electronic copy, just send me an email, and I can get you an individual copy of that book. So just take down my email address and whatnot. All right, so let me give you a little bit of some of the inspiration for some of the patterns in this particular session. There's been a number of clients that we've helped with the architecture of Blazor applications, starting in .NET Core 3, and then going to .NET 5 and .NET 6, and of course starting with Blazor server side, and then as the WebAssembly tooling got more mature and not to the point that it is now, and even Blazor applications for native Windows apps, embedded into WPF and whatnot. We've learned a lot just by actually serving that capacity in Blazor applications. And so I've got some permission to talk about a few of those applications. So I'll show you some screenshots. This one that you see on the screen is in the county fair livestock auction market. And so along with just facilitating the sale and taking of bids and fundraising, this has some really interesting stress points to it from an application perspective. During the auction itself, the auctioneer is going a mile a minute, and this application was actually born in the middle of 2020, when a lot of the fairgrounds kind of shut down and they had to move their auctions online. So what they did was, through a software package, they live streamed the auctioneer and went through the regular thing, but then people cast their votes using either a mobile phone or a full browser. And so along with just taking input, imagine the speed and responsiveness. The auctioneer needs to call out a particular bid, and everybody who's watching it, whether it be a mobile phone or whether it be a computer, the price needs to update near instantaneous. And when someone puts in an outbids by 1,000 or whatever the increment is, everybody who's watching that and everybody who's about to put in a bid, they need to be instantly interrupted because the price changed, and the auctioneer needs to be able to see a notification. So speed and responsiveness was a pretty unique thing. And so a regular web-based application would never do. You either needed native application or you needed super responsive web. And so, of course, this was perfect for a SPI application, as we think in the sense of React and Angular. But now with .NET, well, guess what? I can keep all of my code in C#. We'll talk about some of the patterns for this particular application, but I just wanted to share. And of course, Azure Signalr was a big part of it because it was near real-time notifications. That's one of the applications, just so you see the context. A different application, but part of the same system, was for digital signage. And you can see the picture of the animal. You can see the big Fresno Fair. That's actually in California. And you can see that a little bit of information about the animal, some of the lots that were on deck. The screenshot was at the beginning of the auction. And so there is no user interface to this particular application. And this particular application was Blazor server-side, not because Blazor WebAssembly wouldn't work, but because Blazor server-side gave it so much more reach. A lot of the smart TVs out today have browser applications that do support WebSockets, but do not yet support WebAssembly. Okay, and so if the browser doesn't support WebAssembly, well, that takes that that option off the table. But if it supports WebSockets, well, now Blazor server-side works just fine. And so now all I have to do is point the built-in browser of any smart TV or any screen that could have a Fire Stick or Roku stick connected to it, pull up that little dinky browser that they have built in that supports WebSockets, and now any Blazor server-side app is instantly digital signage on that screen, and the smart TV is already connected to the Wi-Fi. You need Wi-Fi. And then all we have to do, instead of having a keyboard and mouse controlling the application, we have messaging sent to the application. And in this case, Signalr service, again, perfectly meets the need. Now, you're only going to have one or two instances of this application in the Signalr group, but there's an admin screen that's essentially the control panel of what should this display forward onto the next lot, or should it change part of it? We have a little control panel, clicking some buttons, and it sends a message to Signalr service, which this application is listening for a Signalr message to be told what to do next. So that was another interesting application of Blazor, where effectively it was a resident application that just kind of did something interesting, and it was HTML, CSS, C#, and so I wanted to kind of show you those applications. In today's session, we're going to talk about some architectural considerations for when you're thinking about Blazor or thinking through Blazor. I am not going to go through the basic. I'm going to assume, unfortunately, that everyone here has at least maybe done a file new project with the Blazor template and at least looked at it. There's plenty of content out there. If you literally have never even played with it, go grab it. I'm going to assume you at least played with it to do something and to kind of know the basics, because it has been out for a while. I am going to talk about some of the memory characteristics that were surprising, that are different from other .NET application types. And I'm going to talk about applying hub and spoke patterns to Blazor, which has some similarities but differences in other types of .NET applications that you might work with. We're going to talk about different levels of eventing, both eventing into the application and between application components, but also eventing within the user interface of a particular application, and then talk about how to test Blazor application. Blazor is inherently user interface. So we need to test, and that we're going to be testing user interface. And then we're going to talk about some specific things when we're monitoring a Blazor application in production that are a little bit different from other .NET application types. Before I go on, I just want to touch on the type of DevOps environment that you need for a DevOps application. Now, the good news, Blazor applications are .NET. All right, so there's a lot of things that are the same. And this particular architecture poster, by the way, this is only the top third of an architecture poster that I tend to speak about a lot. This is the full architecture poster here, and you can't see any of the text, but it's meant to be printed on a 2-foot by 3-foot big poster board. And by the way, if anybody wants a high resolution PDF copy of it, just send me an email. I'll send it to you. It's fine. This is the top third, and this kind of outlines the DevOps environment that you need for any .NET application that you might happen to be using. And it outlines the steps for the private build, the integration build, package management for your release candidates, and then a minimum of three environment types, because that's the minimum. You can't have a pipeline with less than 3 environments unless your production environment is just NuGet or a library store. If you're actually running the application, you need production, you need an environment that you're going to do manual testing, and then you need an environment where you can do fully deployed automated testing. So that's 3. That's 3 types of environments. And of course, you can have as many more as you want. I've annotated on here the Blazor icon for where in the process you have to do something specific for Blazor. But again, there's plenty of steps where you don't have to do, and I'll touch on those. All right. So let's talk about where Blazor goes in source control. Again, the good news is it is just another .NET project type. So of course today it'll be .NET 6. Coming up later this fall, it'll be .NET 7. But if you're a slow-moving organization, then you'll probably be on .NET 6 for 2 years because Microsoft has announced that the even numbers are going to be long-term releases, and the odd numbers are going to be short releases that they won't give the full 10 years support for. So, but .NET 6 is really stable with Blazor. We want to remember that we don't want to put more than one application in a single Git repository. And by one application, I mean one Visual Studio solution. In other words, something that we're going to build, test, package, deploy as a unit. Now, you could have multiple Blazor applications, console applications in a single Visual Studio solution, and all that architecturally could be one logical application that you build, test, deploy together, and that's okay. But you don't want to have multiple different Visual Studio solutions in the same Git repository. That's not unique to Blazor, but I see it so much, I want to kind of reinforce that. Okay. Now, I do want to highlight the most important difference between Blazor server-side and Blazor WebAssembly that cannot be overstated. And that is, with Blazor server-side, your application is not running in the browser. The only application that is actually running in the browser, consuming memory, is the Blazor framework.js that Microsoft built. That's actually getting served up to your browser, and it's running in your browser. It immediately turns back around to the web server and opens up a WebSocket and sits there waiting for messages. And it gets messages and then tells the browser to add HTML elements to the DOM of the browser screen that's open. And so all these little messages are flowing back and forth, lots and lots of binary messages. If you have never hit the F12 development tools when looking at a Blazor server-side application, I'd encourage you to do so, because you can see how chatty a Blazor server-side application is. It is tremendously chatty, okay? And if you have a problem with latency, well, that should scare you, and that should scare you away from Blazor server-side, because it is chatty. back and forth, back and forth, back and forth, back and forth, back and forth. But the binary messages are tiny, okay? So if you have a pretty good connection between the server and the clients, okay, no big deal. Latency is good on your network for all of the users. No big deal. You don't even care because these messages are tiny. And if you click on one, you may be able to see some things you recognize, like on render completed, and see, oh, okay, that's something happened. We still don't have a good visualizer for these messages. I've been told that that the Edge group is working on kind of a beta of a visualizer for these in the F12 developer tools, but it's not yet out yet. So this is what we have. But remember, none of your code is running on the actual client. Now, what does that mean? Where is it running? It really is all running on your web server, okay? Now, that could be awesome because any of your code is inside your firewall or is inside your Azure subscription, and you can do anything you want whenever you want. That's great. Now, it's terrible if you have a lot of users, because now your web server just got really expensive because you're basically giving them CPU for free. You're giving them memory for free because every bit of their memory, their user session is running on your computers, which in Azure, you're paying for that compute, you're paying for that memory. So when we talk about high scale applications, we have to distribute the CPU load. We have to distribute the memory, and that'll probably, again, scare you away from Blazor server side because you would have to have a lot of memory, a lot of CPU, and which probably means pretty beefy web servers and probably more than one, okay? If anybody has any experience doing significant desktop applications in WinForms or WPF, then you will know just how easy it is for user applications to end up consuming quite a bit of memory. Just go to Gmail, and which is all JavaScript, and look at how much your Chrome or Edge browser, look how much memory it's using just to run Gmail or Microsoft Outlook Online or any significant JavaScript application. They take memory. Now multiply that by how many users you want to support in your application at one time. The memory can get up there pretty darn quick. Okay. Now, at the same time, with Blazor WebAssembly, you have code running in two different places. You have code running on the client's computer, and then you have code running on your server, and you're constantly bouncing back and forth. Okay. So both of these are awesome. And depending on your scenario, both of them could suck. All right. Because they're just different. Now, I've been asked, what's better, Blazor server side or Blazor WebAssembly? And I'm not going to tell you it depends because that's a cop-out. But what I will tell you is you may be talking about your first Blazor application right now, but over time, guess what? You are going to have both. You're going to have some server side. You're going to have some Blazor WebAssembly. You're going to have both. You're just going to use them in different scenarios based on what your priorities are. So it's no which one is better. You're going to have both. Just like asking what's better in .NET 6, WPF or ASP.NET. You're probably going to have both, okay? All right, now let's quickly go into some settings in Azure App Service where I can pretty much tell you always do this. Yeah, you might have some exceptions, but if you have an exception, you'll know why you have an exception. If you don't know why you would have an exception to what I'm about to tell you, then you probably don't have an exception. So and by the way, you're going to be running your application in Azure App Service, okay? Period. Now, when I say period, I mean 80, 90%. 80, 90% of the time, this is the way it's going to be. Now, if you have a special use case and you're doing something else, you know why you're doing something else. Otherwise, you're an app service. You just are, all right? And I know that just 6 months ago, how many months ago was, no, it was only in May, I think, that App Service came out with a new flavor of App Service called Azure Container Apps. That is it's a very interesting flavor of App Service, but the tooling is not quite there yet. So we kind of looked at it, and we used command line and it ran pretty well, but integration with application insights and other APMs and the Azure portal tooling, it has a lot of promise for not having to designate one server at a time inside App Service. With Azure Container Apps, the promise is that you'll be able to designate one, like a half CPU at a time, and just have it dynamically give you more horsepower instead of having to go at the unit of one server, two servers, three servers, and then determining server size. So that has a lot of promise, and that I think that's going to be really cool. But it's just another flavor of App Service. So I think my assertion still stands. You're going to be an App Service, all right? So you want to be on 64-bit platform. The free version, as you create your first App Service and your App Service plan, you're probably going to, so many people use the free version because it doesn't cost anything. But the free version isn't the full App Service. It doesn't have all the features. It only supports 32-bit. And so you can't test your application beyond that, 2-point-something gigs of RAM. I'm not sure if they've gotten up to 3, but 64 gig is what you want to switch it to. And so even once you get past your prototyping stage, you really need to go up to the first production instance size so that you can get all the features, switch it to 64-bit so you can see what your application is doing using the real amount of memory that it needs. You want to also change WebSockets. The free version of App Service does not support WebSockets. What that means is that your self-hosted, for Blazor server-side, your self-hosted Signalr is going to fall back to JavaScript long polling. JavaScript long polling is going to eat up about half of your CPU, just sitting there asking over and over again, is there another message? How about now? How about now? How about now? All right. So you want to switch WebSockets on so that Signalr can run like it's supposed to run. Further, you want to get Signalr out of your process. You want to get it onto Azure Signalr Service and out of your application. Azure Signalr Service, I'd be surprised if I've seen a monthly bill for Azure Signalr Service more than $10. I mean, it's a rounding error in anybody's Azure bill, okay? So just use it. I mean, I've seen like just millions of messages go through where we were kind of surprised that the bill didn't climb. I don't quite understand all the ins and outs of it, but I've never seen Azure Signalr Service be any meaningful part of any Azure bill I've ever seen. So just use it. It gets all that CPU processing off of the web servers that you are paying more dollars for, and then the WebSocket can be for Blazor server side. The WebSocket can just be for the main built-in stuff inside Blazor. Then your AR affinity. Your AR affinity again is off on the free version. You want to turn it on because that is your sticky sessions. Now, if you're doing Blazor WebAssembly, you don't care about this because you don't care about sticky sessions. You actually don't want sticky sessions. But if you're doing Blazor server side, you have to have sticky sessions. Otherwise, you store some of your user state on one particular web server, and then the firewall routes you to a different web server once you've scaled up to more than one. And now you have tons of bugs and your application just flat out doesn't work because you're expecting some state and you could have swore that you were saving the state, but then it wasn't there. Why? Because you're on a different computer. So for Blazor server side, and this has gotten quite a few people because the Blazor server side application works fantastic. And then what do? We use the app service plan and we easily slide that slider bar to 2 web servers. Oh, isn't it so easy? Except now my application's completely broken because I never tested with more than one server. So you want AR affinity. Okay. Let me show you an example. This is a Visual Studio solution for a car auction application. And you can see that it does have multiple projects, but it's not terribly scary. I do recommend, not just for Blazor, but for any application, I do recommend using the onion architecture mentality when organizing your projects and organizing your dependencies and putting as much of your business logic and your entities in a core project that does not have references to every NuGet package under the sun, but keeping it clean, and then having your data access, your user interface, all the other stuff have references that ends up at core instead of having core reference your data access and making it more brittle. But here I want to highlight something. This particular application has two different Blazor applications. One application is called UI, it just stands for user interface, and the other application is UI.admin. This is a strategy for how to deal with role-based permissions, where you don't have role-based permissions on everything, but you have an application that's usable by the general population of users, and then you have some super secret stuff that only your admins should be able to do. Instead of implementing role-based security throughout the entire application just to protect a few things, it's actually simpler architecturally to just create another application that's deployed separately. And by the way, you switch your authorization complexity to authentication. A non-admin can't even log in to the admin site. And that way you basically sidestep the need to do any authorization and only keep the need to do authentication. And so that's just a trick that you can do if you've got a big application and then just have a few things that only the admins or the super users can do. Just carve it off to another application, and where you can keep the main application simple and free from all that authorization mess, and then constantly testing to make sure that this screen or this part of the screen can't be seen by particular types of users, because that's just a whole nother level of complexity. All right, let's talk about memory some more. In dependency management, one of the things that .NET Core came out with was a built-in iServices collection and built-in method for dependency management. And Microsoft basically copied a lot of prior art with the 3 levels of scoping. Going way back to .NET 1.1 in 2003, the IOC containers of the time were using the terms transient, singleton, and hybrid. And so when Microsoft came, they didn't use the word hybrid, they used the word scoped instead. But if you're familiar with any of that history, I know that's back in 2000, that's 15 years ago. No, that's more than that, 2003, 19 years ago. If you're familiar with any of the older terms, just translate hybrid to scoped. And scoped means scoped basically only means this in the life of a web application or a web request. It is the life of a single web request. All right, let me talk about Blazor server side first. Singleton does what you would expect it to. You got to remember that everything's running on the server, and you're going to get one instance for the life of the web process, which is on the server. But if you scale up to a web farm and you have multiple servers, then singleton doesn't mean one globally, it means one per server, because each server is running one process. Okay. Transient's going to do always what you want it to do. Every time you ask for an object, it's going to give you a fresh new instance. Okay. Scoped in ASP.NET Web Services, Web API, ASP.NET MVC, scoped is going to give you one instance no matter how many times you ask for it until the web request is finished. All right, now let's trace a Blazor server-side application. I go to the homepage of the application. I get served the Blazor JavaScript file. That JavaScript file has code which immediately turns back to the web server and opens up, before it finishes, opens up a web socket, okay? That web socket stays open until 3 minutes after the user closes their browser window. So what is the life of a web request in that instance? Could be hours, could be days, could be months, depending on if the user just walks away from the computer and leaves the browser open with no screensaver and whatnot. So if you're using Blazor server side, scoped is not your friend, because there's very, very few instances where you actually want it to be scoped for that line. You might as well be using singleton, because it's just, you're going to get one instance and that's it. Now, Blazor WebAssembly. Blazor WebAssembly, transient means like you would expect it to. Singleton now means something completely different, because the process is now on your user's computer. So where with server side, you were getting one instance singleton for no matter how many users were on that particular server. With Blazor WebAssembly, if you port that exact same application to Blazor WebAssembly, every one of your users is going to get a different instance of the object. So it's going to behave more like scoped was for a server-side application, because you're going to get the same instance of that object for basically the life of the user session, which is the same as the life of the WebAssembly process that the browser loads. Scoped on a WebAssembly application is the life of a web request, but because the web request loads the WebAssembly application, it appears that scoped and singleton have the exact same effect when you're in a Blazor WebAssembly application. So keep in mind those characteristics of how memory is being used so that you can choose the right one. Now, Blazor WebAssembly, no, server side, has a abandoned session 3-minute timeout. There's some pretty cool logic where if I'm using a smartphone or a computer and the internet goes out, or when I lock my phone and I put it in my pocket, basically the web browsers just get frozen. Just to save battery, basically that browser tab hibernates. What it looks like from the web server's perspective is that client just went away. All right, I can't get to that client. The WebSocket is not responding. And so the server is thinking, oh, it went away. And it immediately starts a 3-minute timeout timer. And if that client comes back and starts communicating again, well, it's all great, because the framework is saving the memory on the server. But if that 3-minute hits, well, now all that memory is marked for garbage collection, and that session is gone. You can change that. If you have lots of bounce type traffic, 3 minutes is way too much, because you're going to have just tons of abandoned sessions. If you have people if you have business users, internal users who use your application all day long, then heck, you may want a 4-hour timeout. So just know your users and make that decision, but you can change it. There is something that did get fixed in .NET 5.6, but if you're using .NET Core 3.1 or 3.0, just know that there is a big bug in how Entity Framework implements scoped when it comes to Blazor server side. The helper methods say, oh, just with Entity Framework, add DB context. Well, under the covers, that's calling add scoped. Well, Entity Framework never recommends that you use the same data context for more than one operation, especially not for more than one web request. But because the web request never ends with Blazor server side, that's what ends up happening when you use scope. So Microsoft has come out with a doc that shows guidance on how to use a DB context factory so that you can get the right behavior. And they've built in a new helper method. You'll see it in .NET 6, where instead of saying add DB context, you would say add DB context factory. And so it's a different helper method with the later versions, but just know that that's there. If you're using Entity Framework or anything where the assumption of the framework is to add something as scoped, then you're going to have a factory pattern of some sort. All right, let's talk about hub and spoke patterns. So for Blazor applications, these are rich stateful applications, and these are another user interface type where it's going to be tempting for us as an industry to once again, like it was in the 90s, like it was in the 2000s, application after application after application had just tons of business logic, basically the whole application in the user interface. And then teams and of course managers would go and say, you know what, let's upgrade our user interface technology, or let's change from this to that. And people would go in and realize, oh, wait a minute, if we take away these files, we don't have an application left because everything's in our UI. Now, with ASP.NET MVC, the pattern kind of encouraged people to refrain from doing that because of the various different separations. And even with controllers that were too big, it was a little bit harder to make them massively too big. Whereas WPF, WinForms, and especially the old ASP.NET Web Forms, they suffered greatly with just massive user interface files. Well, the pattern is more similar in Blazor to WPF and WinForms and Web Forms, where right out of the box, you don't have separation between view and controller and the model coming in. And so I think I've certainly started to see it, and I can see the slippery slope that we're on, where it's going to be too easy for development teams to accidentally, unintentionally put way too much code in the Blazor components themselves, when Blazor components are user interface code. So the only code should go there is interface code, adapting the application to the particular interface to what? To a person. Just like Web API, well, guess what? What's API stand for? AP, interface, application programming, or application programming interface. We are interfacing to another application. Data access is a data interface. It's interface code to what? To some type of database, okay? So we got to recognize that code in files that are interfaces should only do the job of interfacing, adapting from the application to whatever the object of the interfacing is, all right? Now, just me saying it here, and this is not going to fix the problem, because 10 years from now, I guarantee every one of you on this call is going to see some application, some Blazor application, where the team put everything in the UI. Yep. If you get rid of those Blazor components, the application's gone because everything's in the Blazor component. But when you're looking at it, think, okay, how can I not end up there? That's where hub and spoke patterns come in. Hub and spoke patterns have been around for a long time, and it basically creates a conduit between an interface and the core of the application, the middle of the application. And so for a user interface, that interface ends up receiving the commands and the queries because a person is clicking buttons, the person is typing in information in text boxes and drop downs and whatnot. And so is originating some type of request for the application to fulfill. Even if it wasn't Blazor, it could be a command line application, and a user is typing things on a command line, generating data and generating requests. But when going from the Blazor application itself into other projects in your Visual Studio solution, I'd encourage you to use a hub and spoke pattern. And the code on the screen is kind of what it looks like. We have the image on the right. We have Blazor-powered screens. We have a synchronous application bus, which, by the way, I love the application bus pattern. It is a great implementation of a hub and spoke, where lots of, and the hub is at the abstraction. Lots of requests come into a class that acts as the hub, and it has just a little bit of intelligence to figure out what spoke to route the request to. And there's two different main types of these hubs. A hub could be a broker if the hub knows about all the different types of requests and knows about all the different types of spokes, and a broker is the one who decides where to route it. A bus, on the other hand, rather than broker, is different because the bus doesn't know about all the types of of requests that it may receive. And it doesn't know all the spokes or all of the implementations of the abstraction that may register. All it does is receive something, it's looking at it, doesn't really know what it is, and then it turns around to all the spokes and says, hey, do you know what this is? Would you like it? Do you know what this is? Would you like it? Do you know what this is? Would you like it? Do you know what this is? Do you like? And that's basically that. And by the way, the bus code, he's kind of ornery. He has a personality, and he tends to talk with weird voices. And the rest of the code really doesn't like him very much. So different code has different personalities. But the broker is kind of bossy. The broker knows everything, and the broker is just telling everybody, shouting what to do. All right. So these design patterns have personalities I like to give to them. But either way, use a hub and spoke pattern. All right. So let's dive into the bus implementation. You only need two different types of methods, really. You need send for the one request to one handler situations, a command like a hey, do this. That would suffice for a command, and then a query that is, hey, give me this object or give me this data. That's also a command, a query that can be sent and has to have one handler. A publish method is where you want to send a request, but there's really no return value, and multiple listeners or multiple spokes can get it. And so events are published, commands and queries are sent. And if that language is a little bit foreign to you, commands, queries, and events, I'd encourage you to go back in the archives of the Azure DevOps podcast and listen to a show by Greg Young. He has done a lot of speaking and publishing on CQRS, which is command query segregation or responsibility segregation. And so you can kind of learn more about just the premise and the thinking behind classifying user requests into those three categories: commands or queries or events. And if you use a bus, and if every screen in your entire application is translating user actions into C# objects that represent what the user is asking to be done, and then all of those objects are being sent to the same method of the same object, well, now you have a place to do tons of cross-cutting concerns. And just an example is logging and auditing to a application performance management service like Application Insights. And so that's what you see here, the record call line. That's behind the scenes, that's Application Insights. And I'll show you how that can be cool later on. But if you want to, send it off to a data warehouse, or, I mean, this is basically your single choke point between your application's user interface and then the guts, the core of your application, where all the logic takes place. The sky's the limit for the cross-cutting concerns that you can put there. All right, this is what I told you, the record call button, where we're translating it into Azure Application Insights event telemetry, so that going to Application Insights, basically now I have a record of every single thing that every user asked the application to do. Because every button click, every time they filled out some form and hit a button, every time they went to a page they had to ask for some data to show on the screen, every one of those screens is translating what the user asked for into an object that represents it, passes it through the bus, and then it's translated into event telemetry and sent to Application Insights on its way to an actual class that can handle that query, use the entity framework, query the database, send back the data to be displayed on the screen. All right, now let me talk about another pattern that's applicable for Blazor WebAssembly. And I don't have time to actually show the code, but if you go to my GitHub account, there is a complete example. And if you go to Palermo.network, there's about a 45-minute video walking through this in detail. But imagine this. You're doing a Blazor WebAssembly application, and it's starting out, and it's all great. It's all hunky-dory. But then let me turn your attention to the last significant application that you worked on. How many screens does it have? Not 3, probably not 5, probably not 50. Your significant applications end up accumulating quite a number of screens. They just do, okay? And I'm not talking about little tiny tools that are used by 1 or 2 people. I'm talking about, the important applications. They have quite a few screens, okay? Now, the default pattern out of the box with Blazor WebAssembly is that a particular screen, think of that fetch data controller, a particular screen needs some data. So that particular screen calls a web service and asks for the data. Now a different screen needs some data. It calls a different web service. Now a third screen needs some data. Now it calls yet another web service. So now let's say, just on the low side, we got an application with 50 screens. I've got 50 web services. Did I set out architecturally to create a web service application? No. I just have to have some way from getting from the user's computer over to my server, and the out-of-the-box template tells me, oh yeah, use a web server. Just do it that way. So what I end up with is 50 or maybe a little bit more web services, and now I got to manage them, and now I got to keep it straight. I probably layer on Swagger just so that I can test them and I can keep it straight. And now I realize that I've got all of the overhead that is necessary for public APIs, as if I have customers that are integrating with my public web services and I'm publishing public web services. I've got all that overhead, but really the only consumers of those web services is me. I don't need to go through all that overhead if I am the only consumer. Just like, if I have a public SDK and I'm publishing it to NuGet and I have customers paying for my SDK, you know what? I'd probably put some investment into documentation for the public APIs of my SDK, just like I put effort into documentation of publicly supported web services. But these are not publicly supported web services. They're basically like private methods for me, like private HTTP methods. Nobody should know about them. Nobody can get to them. I'm structuring the firewall and security so that no one can even find out that they exist. Only my Blazor WebAssembly application is ever going to use it. Ever, 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 ever. So architecturally, it's a big old waste. Okay, so a better option is to, again, use a hub and spoke pattern and create one web service just as a channel to jump over the HTTP protocol. And the good news is, and you can see in the code in the GitHub repository, the good news is we have plenty of applications or plenty of examples that we can just copy from. If you've ever sent durable messages through Azure Service Bus or MSMQ or RabbitMQ, you kind of already know how to do this. You have one queue address, and guess what? You can have tons of reasons for sending all kinds of different message types to a single queue, and the handler that's listening for messages in that queue, guess what? It picks up a message, it routes it to the right handler, and can process them all. So we use the same. Oh, by the way, the Signalr Sdk does the same thing. You don't have 50 Signalr hubs. You have one Signalr hub, but you can have as many methods on your actual hub class as you want, and you can send as many real-time messages over Signalr as you want on one hub. Okay, so this is the same pattern. Just have one web service, and that web service is not strongly typed. That web service doesn't actually know what the command or the query or the event that you're sending over the wire. It just knows that it's going to receive something, and then it's going to pass it on to the bus on the server. And then your bus can route it to the right handler. All right. So I'd encourage you, if you're using Blazor WebAssembly, to intentionally think, hey, do I have a scenario where these web services are kind of like private methods? They're just for me. They're not public to the world. If so, just use one and use the steal the pattern from the Azure Service Bus SDK. It's open source anyway. You literally can look at how they do it. All right. Now let's talk about eventing. Within the user interface, this is another situation where you might want to talk to some of your coworkers who, I don't know, have 15 years of experience or more and did some significant work in Windows desktop applications, because there's a lot of stateful native desktop applications where the UI was tremendously sophisticated, and you had panes on the left side, and you clicked on something, and if you clicked on something on the right hand side of the screen would instantly change. There was I wish that I could find it, but it's so old. In the late 90s, there was a case study done about Adobe Photoshop and the engineering of the Adobe Photoshop user interface. And every individual piece of the Adobe Photoshop interface was a controller and view pair, where the view was the little portion of the screen that you could see, and the controller was a class behind it that had the intelligence of what to do when the user interacted with it, and what messages, what events to listen for that were happening in the other parts of the user interface. That architecture is probably one of the big reasons why Adobe Photoshop is still so successful today without having to have been completely replaced and rewritten. Whereas if anybody's used Intuit QuickBooks, we know that architecture of Intuit QuickBooks was the exact opposite. They became trapped because they could not change. Still to this day, they cannot change the user interface of Intuit QuickBooks Desktop Edition. And they basically had to invest a ton of money and build from the ground up a web edition. And they're still working on catching up with the feature set that the Desktop Edition had, because they could not refactor it because of the patterns that they had chosen. And probably no one on this call has ever had to participate in a rewrite project. Certainly no one. We're in a different company here. But the architectural choices that you make, well, they have those kinds of consequences. So the UI in Blazor is stateful. And as such, you want to use some of those desktop application patterns. Now, React has some of these patterns built in. Angular has some of these patterns baked in. So lots of people are doing it. And so there's plenty of examples to learn from. Expect to have UI eventing in your Blazor application. Now, it starts with factoring your screens into many components. Don't worry that you have too many components and that your application might be a memory hog. Your application is not going to be a memory hog because you factor a lot of components. Your application is going to be a memory hog because of how you use the data that you get from a database and how long you keep it around and things like that. Not because of the actual framework that Microsoft created. So you want to start by factoring literally every section of the screen into a discrete component. And you can just draw it with a pencil and start drawing boxes around each other and say, okay, this part of the screen does something unique. This other part of the screen does something unique. Then you don't ever, when I say ever, I mean ever, you don't ever want to have a parent calling a child component to then tell another child component to tell another child component to do something, only for that child component to walk up a couple ancestors and then over to an aunt or uncle and then down to the grandchildren just to pass a little bit of data. Okay, that's how you get spaghetti UI. Instead, you want to have every Blazor component there register on a synchronous UI bus, yet another hub and spoke, but not a vertical hub and spoke going down into the depths of the application. This is a horizontal hub and spoke that's just for the user interface. Have every Blazor component register on that bus, and then any component that's in memory can send an event, and instantly another component somewhere else in the screen instantly receives that C# class, that's an event, and can look at the properties, get the data, and decide what to do. So in this particular component right here, we see at the top a refresh timer. All right, see that tag? We're going to drill into that refresh timer tag. This is just actually this comes from the car application, the car auction application, where we're showing the details of a particular lot in an auction. There's a refresh timer. We're going to drill into it. This is the entirety of the refresh timer component. notice that there is no HTML. There is zero visible part to the refresh timer. Its only responsibility is to get a little bit of configuration from the app settings.json file so that we know how many seconds to wait until triggering a refresh. But it doesn't trigger refreshes. It doesn't do anything. The only thing it does, right in the middle of the screen, bus.notify, new refresh timer triggered. Events are always past tense. Refresh timer triggered doesn't need any properties. It's just an empty marker object. That's all it takes to have an event. It's just a little tiny nothing of an object with a name that's sent bus.notify. Okay. Now inside bus.notify, bus is literally just doing a for loop for all of the components that registered with it. And what does it do? It goes around, hey, I got this object. I don't really know what this object is, but do you want it? Do you want it? How about you? Do you want it? Do you want, oh, you want it? Okay. Oh, you want it too? Here you go. That's all the bus is doing. All right. So here we have a Blazor component. This is just a section of it. And all it does is implement iListener of a particular type of event. And by this component putting itself on the bus, it's basically telling the bus, hey, look at all the iListener implementations I implement. These are the types that I'm interested in. And so one of them is handle refresh timer triggered. And you can see all of it. Refresh entries, meaning I can change something about myself because it's time to refresh myself. So I know how to refresh myself and I can do it. Okay. So that is super simple to send messages from literally any subcomponent to any subcomponent. You can be decomposed 5, 6, 7, 10 levels deep, and instantly every single component that's alive on a particular screen on the stack can send unlimited number of messages. And by the way, you only have to listen. A component only listens for the events that it cares about or knows about. So obviously it's not even going to receive every message, just the ones that it implements an iListener for. All right. Now, if you don't want to implement this stuff yourself, there's a NuGet package for it. It's called Blazor MVC. Blazor MVC, I love it. This actually came out of a client project where there was a lot of complexity in the user interface. And so we helped them separate view logic from controlling logic. And guess what we came up with? We came up with a model view controller pattern for Blazor. Because, it's not rocket science. It's just, hey, let's keep the stuff that makes it look a certain way in the markup file. And let's keep the C# that does certain things in a C# file. Not rocket science. And then the model is, the entities and events and the commands and the queries and whatnot. So go to NuGet and, spoiler alert, I'm the publisher of this one, just because I had a NuGet account, my name's on it. But so check it out. All the code is on GitHub. You can look through it. You don't even have to use the library. Just go and look at how the bus implementations are put together and just steal some code. That's the beauty of open source. Just go and learn from how it behaves. And there's samples for everything. There's samples for WebAssembly, for server side, for .NET 6, for .NET Core 3.1. So hope it helps. All right. Now, separating controllers from views. This is what the code looks like. The counter controller that's in the default project. We factor out from the component a C# class. We call it counter controller, and we rename the markup file to be counter view. Now, both of these classes end up inheriting from component base. So both of them actually are Blazor components, and that @page symbol in a Blazor component markup file, well, that gets compiled down into a route attribute on the class level anyway. So this literally is the same route attribute. But the interesting thing about this is that the controller gets on the call stack first. That's something unique about model view controller patterns from MVVM, model view model patterns, or model view presenter patterns. because there's some other flavors, but in all of those patterns, the view goes on the call stack first and then delegates to the controller. In model view controller patterns, the controller comes alive on the call stack first and then delegates to a view. So this is a model view controller pattern, not a model view view model pattern. And so as such, the controller comes alive first and gets to choose which view to implement. Now, in a lot of cases, you have a default view and there's only one view, and that's fine. But in the cases where, based on some logic or how the data comes back from the database, it may be better to choose view A versus view B, so you have that freedom. All right, won't go into that a lot more. Now, let's talk about how to start up a Blazor WebAssembly application. All right. And we'll kind of start wrapping up after this. Blazor WebAssembly application, right out of the box, you get a client project and a server project. In this example, I've called it user interface, UI. I've called it UI. So out of the box, the template gives me a .client and a .server, and it puts the Blazor components in the .client, and it puts the startup logic and the web service in the .server. Now, I have a problem with that, because now I have a project .server which has two really, really important responsibilities. The first responsibility is to be the web service so that the WebAssembly application can call over the wire and get some data. All right, that's a big responsibility. And as it grows, there's more to go in there. It also has a responsibility of starting up the entire application. So the program.cs, all the middleware components, wiring up logging, populating the iServices collection with all the different dependencies, add singleton, add transient, all that stuff. That ends up being a pretty significant part. Wiring up the .NET 6 health checks, everything like that. Starting up the application and wiring everything together is an important responsibility, and we've got that put in the same project as my web services. Whatever project has the responsibility for starting the full application has to have a reference to every project in the Visual Studio solution, because that's how you wire up the iServices collection so that you have dependency injection, okay? So you have a project which is promiscuous by nature, which has a reference to every single other project. And in that project, I have web services. How am I going to expect any member of my team to not use all of the code that is referenced straight from a web API controller when my IntelliSense is constantly popping up? Oh, would you like to use this type? Would you like to use that type? How about this type? How about that one? And we said, no, ignore IntelliSense. We don't use that layer from what we use only. Okay, you're setting them up for failure. So a better way to do that is factor out another .api, factor out another project and make it a web project, and then move the web services over to that project and have that project only reference core. And that trims down the .server project to only having the responsibility of starting up the application. And that creates the dependency diagram that you see to the left of the screen, where the UI.server, the .server project has to have a reference to everything, and we give it the responsibility of starting up the application, but that's it. And then we have other individual projects which do one thing and have cohesive dependencies. Data access has a dependency on entity framework, and then of course our core application, which has our entities and other things. UI.api has the web services and references core. UI.client, our Blazor application, references core. And as a side effect, which is really great, the project where our web APIs are doesn't have a reference to our .client project. Whereas by default, the .server project has a reference to the .client project. But we don't need our web services to know the types of Blazor components in the .client project. It's just not necessary. So I highly encourage you to refactor your Blazor WebAssembly Visual Studio solution structures so that each of your projects only has one major responsibility. Let the .server project have the responsibility of starting the whole application, and let a new project have the web APIs. Okay. Let's see here. All right, let me jump to how to monitor these applications. All right, we talked about more memory, we talked about latency. Let's get concrete. When it comes to choosing instance sizes, you want to use the V3 instances. You go back in the podcast archives, you can see I interviewed Stefan Shakow. He's one of the main architects on Azure App Service. And I just asked him, flat out, hey, what's the minimum server size that you would host Blazor applications? And he said, well, you're doing Blazor WebAssembly, all you're hosting is Web API, and those servers can be pretty darn small depending on what you're actually doing. And so you can use all your past learning for that, small servers, actually, and go to town there. If you're using Blazor server side, the smallest you should use is P1 V3. And those came out about a year ago. The V3s came out a year ago, gave a lot more horsepower, gave a lot more CPU for the same price. But P1 V3 is the smallest he recommended if you're doing Blazor server side. And that's what it looks like. P1 V3 has 8 gigs of memory, and which is more than twice as much as the P1 V2. Okay. All right. How to monitor. For Blazor WebAssembly applications, your server-side monitoring is just Web API monitoring. So the good news is pretty darn simple. For Blazor server-side, monitoring is totally different. For Blazor server-side, the latency is such an important factor that you need to keep your server response time down below 10 milliseconds. Okay, we found that it seemed pretty reliably if the average server response time was over 10 milliseconds, we as humans started to be able to perceive a slowdown of responsiveness of the application. Because remember, every time, even though those messages going back and forth on that WebSocket channel are tiny, it still does require the server to use some CPU and do some processing and turn back around. So it's not like it's a whole lot of processing, but if the server is doing any kind of queuing whatsoever, well, the users of that are going to notice it on the other side. So keep your server response time down below 10 milliseconds, and your users, they won't notice anything. It'll be super, super snappy. The average receiving response time includes receiving HTML data and all that. We found that keeping it below an average of 100 milliseconds, the users could not perceive that anything was going on, and it felt super, super snappy. So those are some heuristics for Blazor server side. Remember that your auto scale, if you do a custom auto scale, you can scale based on CPU, you can scale based on memory. As soon as you scale up the instance size, your rules basically break. Because if I'm going to go on the amount of memory consumed to spin up another instance, or percent memory consumed to spin up another instance, and I go down to P1 V3 and I start having a surge, that may, if I have it tuned for that, it'll rightfully add a second instance and a third instance. But if I go up to P3 V3, it has so much memory that none of those custom auto scales are even going to really apply. So what we found is that you kind of have to plan out what instance size you're going to run. And if you're going to use the custom auto scale, tune it to the instance size and just stick with that instance size if you really want to depend on custom auto scale for Blazor server-side applications. And in practice, what we've ended up doing for the Blazor server-side applications is just kind of predict when we're going to have a higher number of users and just use manual scale and with some scheduled PowerShell and whatnot. All right, I talked about application insights. This is the last concept here. And I talked about transforming all of the commands, queries, and events that go down a bus to telemetry and sending it over. This is what you get for free if you do that. You get charts where you can graph anything that the application is doing. Look at this drop down here. Register new buyer command, running totals. Oh, at the bottom, submit new bid command. These are commands. The user clicked the button to submit a new bid. And so you can choose which of these events or commands or queries are relevant and create a bar chart, a line graph, whatever you want to over time. And now we can see that over the course of the summer, we had increasing traffic. Oh, but we had some seasonality. Well, guess what? Turns out certain days of the week were more popular for auctions than other days of the week. So we could see that type of seasonality as well. And all we did was make sure that every button click and everything that the user did was encapsulated in a command or a query or an event, pushed to the same abstraction, a bus pattern, and then layered on some cross-cutting code that transformed it into our APM logging, send it over to Application Insights. And now Application Insights does what it does really well, allows us to make all these fancy charts. Why? Because it actually had a record of every single thing that every user did. Okay. Now you see the green little check marks across the top. That's a cool thing that you get for free if you're using Azure pipelines. Every time we deploy to production, we send a little marker to Application Insights. Hey, I'm deploying version such and such. And we get a little checkbox knowing that there was a production deployment to this particular, or a deployment to this particular environment that we're looking at. So if we were wanting to change some particular metric by doing a production deployment, then we could kind of correlate that. Now, I talked about monitoring the number of users, and on Blazor server-side applications, we're using a lot of memory and we're using the server's CPU. And so we kind of need to know how many user sessions we're supporting at a given time with that type of application. And so a custom circuit handler is how you do that. There's an abstraction that the framework gives us where we can do some logic every time a new user session connects and every time a session disconnects. And so what we've done is we've captured that number and thrown it over to Application Insights. And now Application Insights can give us a line graph of how many users are connected. And when you have multiple different server instances, it can also split it by that. And so we have open circuits, connected circuits, and disconnected circuits. A circuit can be open, but not connected, i.e. the phone's hibernated in your pocket for 3 minutes. That circuit's going to be open, going to be preserved, but it's not currently connected. And if it doesn't stay connected for the timeout, it's going to end up being classified as a closed circuit, or it'll be disconnected for those 3 minutes until it gets cleaned up, and then it won't be an open circuit anymore. And so for our dashboard, we tend to put the connected circuits and the open circuits and the disconnected circuits on there. And we love to see it by web server. With Blazor server side, remember, you have to use sticky sessions. What does that mean? If you need to scale up and you've got some number of sessions on a server, and by the way, you look at it and you're thinking, man, I've only got 16 sessions on this. What we have tended to do is figure out the smallest server size that our application can be healthy at, which P1, V3 is what we target. We do performance tuning so we can stay on P1, V2, and then just let it add another server. But we already have 16, 20, 40 sessions on the first server, and then we spin up a second server. Until people disconnect and reconnect, no sessions will get assigned to the new server. Why? Because we've got sticky sessions assigned, and all of the state, all of the memory is on the first server. And Blazor does not have any kind of self-balancing logic. It's not going to happen. It happens organically because somebody hibernates their phone, they put it in their pocket, 3 minutes passes, gets cleaned up, then they pull it out of their pocket, the browser tries to connect, doesn't happen, the JavaScript logic that it has loaded, refreshes, then they get a new session, and then they just get assigned to whatever server, and it's likely the different server. So it kind of auto balances over, the course of 10 minutes or so, because you have those timeouts. All right, the circuit handler that I talked about, you literally just inherit a C# class from circuit handler, register it in your iServices collection, and do a little bit of logic by overriding on connection up and on connection down. Do whatever you want with it. All right, lots of information there. I know if you want to go grab the Blazor session of Programming with Palermo, go for it on www.palermo.network. And my email address I'll leave up on the screen so that you can, if you want that high resolution DevOps poster or electronic copy of the book, go for that. And let me catch up on questions that I didn't get during the presentation here. Question about sensitive data. What patterns can help us handle these issues on sensitive data? Okay, so Blazor doesn't introduce a different way of thinking when it comes to sensitive data. Where let's just even go back to ASP.NET MVC. If you had some sensitive data that really needed to be on the client's computer, that needed to be shown to a customer. So let's take a banking application. If you're logged into your banking dashboard, you kind of want to see your bank account numbers, right? But that's sensitive information. You don't want somebody else knowing what your bank account numbers are, but you need to see them. So the same thing holds with HTTPS. Do not go back and forth to your own server with a non-encrypted connection. In this day and age, you should have no non-encrypted channels of any kind. They should always be encrypted. If you're going from outside Azure into Azure, you want to encrypt every single channel. And then if you have some channels, from one server to the other inside your own Azure subscription, just make sure that your firewalls are protected as such. But Blazor inherently doesn't change how you think about handling sensitive data on the client side. Now, I will remind you of a few things that are going to be kind of like a blast from the past. Back in the WinForms days, in the WPF days, there was lots of talk about obfuscating your code, and there was even a obfuscator product that was embedded into Visual Studio for a time that would take all of the assemblies and would change every name of any kind of method that you could possibly decompile a DLL, so that even when people did decompile the DLLs, they really couldn't make sense of what code was handling a bank account number or anything else, because you were shipping those DLLs to a user's computer, and the user could look at those DLLs and try to make sense of what you were doing and maybe do some hack attempts. Well, the same thing is true now for a good number of years with JavaScript SPA applications. It's the same concerns with React and Angular. The entire application that you're running on a user's computer, well, guess what? You're shipping all of the code over there. So the JavaScript community has done the same thing. Minification of the JavaScript is effectively obfuscation, and it makes it to where it's hard to see what's going on. However, you can still, if you have the code on your computer, you can change the code. So you want to make sure that you don't make sure that you authenticate and authorize before you actually grant access to data. So Blazor doesn't do anything different or special. It's going to be a concern regardless of what application type you go after. Let's see, another, do you see cases where you need to use obfuscation? Well, yes. If you are concerned about intellectual property and you want to use a Blazor WebAssembly application, then you're probably going to be interested in obfuscation. Now, if all we're doing is moving data around and taking instructions from a user and giving instructions to a server, that's not intellectual property. I mean, but if you had some proprietary algorithms that you've invested a lot of time, and that investment was in a library, and that library needed to execute on the client side, then absolutely I would do some things to obfuscate the heck out of that thing. I'd probably obfuscate the library. I'd probably try to embed and combine or combine the assemblies into one. There's some tricks that you can do to build multiple assemblies into a single assembly. Heck, I might choose to not even send that library over to the client side and see if I could put something behind a web service and just keep it on the server and then ask the server for the results. But again, you're going to do some of those things if you do have significant intellectual property in the code that you're thinking about putting on somebody else's computer. And I think you're going to know if you're in that situation. Let's see, how many users can Blazor server-side handle without costing an arm and a leg? Well, you're going to have to do your own math on that, on how much data you're pulling into a user session and how long you're keeping it around for. If all you're doing is saying, hey, user, sign my guest book, and it's a title and a message, and sign my guest book, you're not going to put much load at all, and you're probably going to be pretty close to Microsoft's own benchmarks. And I can't remember the numbers, but they've I want to say they've actually published how many thousands of users that Blazor server-side can support on the different app service instance types. I'd have to go and find those links. I just haven't been worried about it because what I do with my data in my application is what answers that question, not that Blazor server-side intrinsically does something or not. It's actually pretty darn efficient, but you just got to know as I keep some of my users' data around in their user session, however much data I'm keeping around, well, just multiply it by how much memory I want to use on that server, and you can kind of get to your ceiling threshold just by doing some math. All right, looks like we got to the end of our questions, unless any come through.
Yeah, I could see one real quick just to give everyone one last chance to get some questions before we let you get out of here. But when you were bringing up some of all the custom instrumentation stuff and app insights and all that, that definitely gave me all sorts of flashbacks because that's the world I live in. I've instrumented the heck out of all sorts of client and server side applications, and it made me wonder, like, I think what you were showing there at one point was the server side timings, which I'm guessing were taken from the Azure side. Maybe I'm wrong, but it got me wondering if you've found any value in doing client side timings as well to look for any potential like gaps between what it really feels like from a user perspective and a server responding very quickly. Or do you find that in this WebSocket world that there is very little delta just because you have a persistent connection as opposed to if you were making REST calls and those sorts of things?
So for the WebSocket portion and just regular code executing, we really don't notice it. Let me pull up. I have something on the side. Actually, this is okay. I think that chart just pulled up. There is something that's Blazor kind of triggers this, but Blazor is not the cause of this. All right. In this scenario, this is the F12 developer tools, and this is the performance tab. You can see at the top, the performance tab pulled up of Google Chrome. And this shows the HTML DOM frames or the HTML DOM methods that are being called as elements are being added to a particular page as we load data. And so in this particular instance, this is actually the county fair livestock auction application. And we show 100 animals per page. We have a paging scheme. And We don't show them in a grid. We show them as tiles with the image of the animal and some data around. So 100 tiles, and then responsive design depending on how big the browser is. All right. So what that does is it creates 100 tiles of HTML, so that those sections of HTML 100 times get added to the DOM. The slowest part of applications that run in the browser is changing what is in the DOM. I mean, it is super slow. So this is not unique to Blazor. It is going to be present on any type of application that dynamically changes the DOM. And so every Angular app struggles with this. Every React app struggles with this. That's why if you're using, just let's say if you go to a facebook.com timeline and you load it up, the first thing you see is just some gray bars that are animating back and forth. What they're doing is they're lying you and say, hey, look how fast our website loaded. Look, it's right here. But there's nothing there. It's just a placeholder animated. Why? Because their website is dog slow, but they have to trick you into not immediately being disgusted at how dog slow it is. And then you have to wait, and little animating gray bars. And then finally, some data replaces it, and then you can start using the application. But because you saw something, you didn't instantly say, why isn't this loading, right? So you have to lie to your users sometimes if you're using the techniques that make it dog slow. But there is a way to actually make it fast and not actually lie to your users, but satisfy the users, and even while it's slow. Let me give this example. All right, you can see along the top here, 5,700 milliseconds from the beginning of the action. Look over here, 6,200 milliseconds. That's half a second. You can perceive half a second. We can perceive 50 milliseconds is generally around when we can perceive that something isn't instantaneous, about 50 milliseconds. So at 500 milliseconds, I'm definitely noticing, all right? So this is on a server with zero. This is actually a local development environment here, right? Nothing's going to be faster than locally on your own box. And here with no data at all, we're half a second delay. We got to fix it. So we have 100 tiles that are being loaded, and all of these insert frame, insert frame, insert frame, insert frame everywhere. It just takes the DOM in Edge or Chrome. It just takes it a long time. Why? Because it's having to add all the HTML elements for all 100 of those tiles, all those image tags, all those span tags, those P tags, everything as a user interface transaction. And it doesn't actually show the user anything until it's done, okay? So how do we get it to be done faster? Well, Blazor gives us an interesting thing called state has changed. And this is a little interrupt where we basically tell Blazor, hey, I know what I'm doing. State has changed, so go ahead and wrap this as a transaction. Wrap this as a DOM transaction. So what I can do is I can get the data from the list. I have 100 items in there. I can just take the first 10 and put it in the collection that's bound to the markup, and then state has changed. And so now I only have to do 10 tiles, and then the user sees something. That's 1/10 of the data, 1/10 of the HTML elements. And instead of 500 milliseconds, 1/10 of that is 50. Now we're at the point where it's indistinguishable from instantaneous, and that's a DOM transaction. And then I can bind the collection to all 100 on the next item here, and then call state has changed again. But the user is already looking at all the beautiful animals, and they're distracted, and they don't see the scroll bar on the right-hand side of the screen get smaller because the screen below the fold that they couldn't see just got longer. They see 2 rows of 5, which is all they could see anyway without scrolling, and there's no way they can get over to the scroll bar or reach for the page down button before the rest of the page actually loads. So we kind of fake it, but instead of lying to the user with this moving back and forth gray bar that's loading, instead, we actually do give them something to look at instantaneously, and then just load the rest of the screen in the background.
Well, it looks like we just had a couple that can probably be answered together, and then probably work our way out. But
do you recommend
yeah,
Blazor over React? Yeah.
loaded
I
question.
mean, why? I'm a .NET developer. Why do I want to not use .NET? Come on. All right, next question. When should I choose Blazor app versus a regular SPA? A Blazor is a regular SPA. All you're doing is choosing platform, dev and test tools, language. And if you're a Visual Studio developer, choose a Visual Studio application type. That's my answer for that one. And then what is the main focus of Maui and Blazor hybrid app? Okay, so this is Blazor native, and this is really cool. We've already helped a client do a WPF Blazor native application. It was a Windows 10 and 11 application that has a little icon in the system tray, and it just sits there behind the scenes and does something. And if you click on it, and it pops open a little screen, everything visible, whole screen, is a Blazor screen. It's a Blazor component, but it's wrapped in the shell of WPF. But it's also native code, so it's not running in a browser emulator. It's actually running on the disk, so it knows what Windows user is logged in, and the C# code is running as the user account of the current user. And the really interesting things is that it can interact with the Windows 10 and 11 Action Center. It can listen for messages, coming in, and it can pop up Windows native notifications because it is a Windows native app. But the team involved, which is very adept at HTML and CSS, did not have to learn WPF SAML or WinForms UI. I mean, come on. To be fair, those UI paradigms are very different. So if you've got developers who are already really comfortable in HTML and CSS and C#, it's just a hands down winner. So that same concept is for Maui, except we have the Android and iOS application shell and all of the availability of the smartphone services and pop-up notifications and all that integration and GPS and everything, camera, microphone. We have all those services that are just C# APIs at that point, and everything visible, guess what? It's just HTML and CSS and behavior in C#. So you take that, throw in some Blazor MVC to separate the views from the controllers, and now you've got a regular .NET application with some CSS and HTML just packaged in the shell of a smartphone application. So the real unique stuff that you have to do if you've never done it before is know how to test and deploy and monitor applications that are going through the Google Play Store or the Apple Store. But as far as developing the application itself, again, you're now making use of the main .NET developer skill sets for more application types.
Awesome. Well, I think that that wraps it up for everything that we had there, and I think that's a pretty nice, succinct closing point too. So, Jeffrey, just want to say thanks again for coming and hanging out, delivering all this awesome content. Looks like there's a lot more, so maybe we'll just have to get you to come back and talk about some more Blazor stuff. Thanks for everyone for hanging out. It was awesome to see the attendee count. Really stick around and ask a lot of awesome questions and be really engaged. So really appreciate everyone coming out. Like I mentioned, the video, this will be up hopefully over the next few days, at the very least, early next week. I'll post it to all the normal places, and keep an eye out for for stuff coming up on our schedule real soon. Keep an eye on Twitter and Meetup and everything. But Jeffrey, thanks again so much. This was some really fantastic content, and it had been, I think, a little over 2 years since, actually more than that. I think it was our last in-person meeting before the pandemic, the last time we really talked Blazor. So we were long overdue and definitely ready for a deep dive. So thank you so much.
Oh, my pleasure. Glad to be here. Thanks for having me.
And thanks again to everyone for hanging out, and we'll see you real soon. Have a great night, everyone.